Well, good morning, everyone. Welcome to Science Wednesday, and we have a very special youth presenter today. This is Cynthia. Everyone say hi to Cynthia. I'm really proud of her for stepping up and volunteering to do this. So Cynthia today is going to introduce us to the world of electronics. It's amazing how the discovery of the electron has enabled the world and technology to advance. It's amazing. So we're going to get a little introduction into circuitry today, which is basically everything that controls our smartphone, to our computers, to everything. So I'm really looking forward to dabbling in some things that Cynthia has planned for today. Before we get going on this, I want to just show everyone some updates to what's coming online. So this is on youngscientistsacademy.org/programs. So you'll see today we have Cynthia, but please join us tomorrow and on Friday. Tomorrow we have Steve Paff from the National Weather Service, and he's going to be talking to us about the science of weather and ocean currents. So that's going to be a really good one. And then we also have our second lesson with Dr. Caro. She's going to be continuing our scientific illustration lessons, and also going to be joined by Abby, who's going to talk a little bit about, I think she's going to show us how to do caricatures, like with comics and things like that. Sorry, I got a frog stuck in my throat there. And then on Friday, we have a talk about civil engineering. So Mr. Bill Darrow, who's a great supporter of YSA, is going to be joining us and giving his 40+ years of experience in this field. Everything from going to college in the first of his generation to his work with DC Water. So that's going to be awesome. The other thing I want to show you is we also have uploaded all our lectures so far and put them on our website. So you can see this on our virtual experiences section of our website. And, you know, so there's yesterday's lecture with Dr. Julie Burwald, which was awesome. There's some resources there. So I encourage everyone to check that out and watch the videos and ask any questions that you have there. So that's really cool stuff. So without further ado, I'm going to hand it over to Cynthia, and I believe she's going to kick things off by showing something with a fan here. All right, Cynthia.
First, I'm going to talk about electricity. Well, electricity is defined as the flow of electric charge. Charge is the property of matter, just like mass and volume. Well, first,
Cynthia, do you want to just speak up a little bit into the microphone? There we go.
Okay.
And you can put the paper down a little bit. There we go. All right.
Well, circuitry is a collection of electric circuits. A circuit is a closed path that allows electricity to flow from one point to another. It may include various electrical components, such as transistors, resistors, and capacitors. But as the flow is impeded by a gap or break in the circuit. A circuit is also a path that electricity flows along. It starts at power source, like a battery, and flows through a wire to a light bulb or other object and back to the other side of the power source.
Explain the battery.
Very good. Okay, so what do we have here? What are you going to build for us first of all?
First, I'm going to build a light.
A light. Excellent. Good.
That I talked about before. that I talked about before. This is the battery pack B1, which holds the batteries, and this is the L1 that is the light socket. So I just
So that, oh wow, that's pretty cool.
All I do is snap it on and then.
Very, very simple. So can you maybe hold that up to the camera a bit so we can see up close what it looks like? So you have a power source here, which is the battery, and then it's connected directly to a light source. Huh, that's actually very interesting. So what I'm going to do here is maybe I can bring up I'm going to share the whiteboard and sort of explain what's going on here. So you have to excuse my poor drawing skills. I'm still getting used to this. So here is the power source, right? So power, in this case, the power source is a battery, right? And then you'll notice that the battery has a positive and a negative end to it. And from there, you have, let me see if I can draw a line here. So there's some sort of wire, and then that is connected to a light bulb. Looks more like, I don't know what that looks like, but that is a light bulb here. Okay. And then that wire connects back to the power source. Okay. So what is actually happening here is that you have a flow, you have a current that's going through the wire here, and it's causing this light to become bright. There's heat being exchanged, and then that power returns back to the battery. So this is a closed circuit, and the reason why it works is that there is a flow of electrons through the wire. So if I could draw an arrow. So these little electrons are flowing through the wire, they're being conducted, and they flow into the light bulb. It gets hot, light is produced, and then that flow of electrons move back, right? So this type of circuitry here is called a series. It's called a series, right? So in this case, everything is in line here. The light bulb didn't work until you put it in to complete the circuit, right? Now, it didn't work in this case because the flow of electrons couldn't complete, right? It was an incomplete circuit. All right, so that's pretty cool. All right, so what you built there is a very, very simple series circuit that allowed the flow of energy to go into the light works, and so on and so forth, right? And this is how it works in the house, so to speak. All right, very cool. So did you have another one you wanted to show us today? Right, okay, go ahead.
This one is called the sucking fan.
Oh, very good. All right.
Well, I couldn't build it for you guys today, but I did build it for the class. Well, I could tell you the parts of it.
Yeah, sure thing. Yeah, let's have a look at the parts here. So before you get going, so what actually got you interested in all the the physics and the electronics and things? What interests you with this?
I'm not really sure. It just snapped in my mind or something.
Yeah, that's pretty cool. And these things that you're building here, these are part of a kit. How can we get this type of stuff? Like this fan that you're building, is this part of like a kit that you got?
Yes, for Christmas. Well, first I thought it was kind of boring, but it was kind of really interesting.
And And how many things, is this the box behind you on the couch there? You want to show everyone, hold it up to the camera. There you go, snap circuits. That's pretty cool.
The classic.
And build over 300 electronic projects. This is very cool.
My brother has snap circuits. He got them for Christmas too.
You know what? I have one too. Yes, I should have brought it out for this. Very good. Okay, Cynthia, so let's walk through this sucking fan. I'm very interested in this.
One.
I'll point you top.
Okay.
Which one?
R1 is the resistor.
Ah, resistor.
Okay.
Mhm.
What's next?
Q1 is the transistor.
Okay.
RV is the adjustable resistor. S1 is the slide switch. M1 is the motor. These are the snap wires. So I need 3 of those.
Okay.
This one is the battery pack, which you already know of.
David. Kind of funny.
And this is the fan for the motor. Do you want to see how it works?
Absolutely. We totally want to see how this works. Yeah.
Is it okay like this?
Go for it.
Okay.
Yeah, that looks great. Oh, hello. So which way is the air going here? Is it going
It's a
top
sucking
down?
down.
Uh-huh.
That's very cool. So this might be something that we might see in a fume hood, right?
It's on and off.
So,
Yeah.
So just
If I put it up, it goes faster. If I put it down, it slows down.
And turns off.
That's right. Yeah. So how do you turn it on and off? Can we show that again?
First I put this light switch on. Well, it doesn't start until
adjust.
it doesn't adjust until I put up like this.
There you go. Okay. So the switch there is enabling a current to flow through the wire. And this would be another example of something that is in series because it's just one basic loop here. But there's a couple of really interesting things here, right? The first is that yellow thing there. Can you point to the yellow thing?
Yellow thing.
That's the resistor.
Okay, so this is called the resistor. And so in this case here, our light bulb would be the fan, right? Okay, so a resistor has this little symbol on top here, right? Looks like a squiggly line. And what the resistor does, it actually restricts the amount of current that can go through the wire, right? Now, the amount of current that goes through the wire is called amps, right? The flow of electrons through the wire are amperes or amps, right? And the ability of something to, and this is symbolized by the letter I, by the way, right? I. And then we have another thing called a volt. A volt. And what a volt is the ability of that current to flow through the wire, okay? Right, so it's including the flow of things. So there might be a lot of too many electrons, too many amps to go through this, and you might actually blow the fan out, right? Okay, and so you need to restrict the flow and the voltage of the current through the wire, right? And that's exactly what this resistor is doing. And when you put that little knob back and forth, you're actually altering the resistance of that current that's going through the wire. That's pretty cool. All right, so resistors are really, really important. we also see this, like, you can adjust the speed of a fan in your home, right? Sometimes you want the fan on high, sometimes you want it on low, right? All you're doing there is you're altering the resistance of the wire that enables the motor to spin at a certain rate. Adeline has a question, so I will let her unmute and ask the question.
How does the, like, is there something that pushes the electricity through it, or does it just go on its own?
Good question. I will let Cynthia have a crack at that one. Do you know the answer to that?
It's built off the batteries when it's going through all the way here,
Through all the connectors.
through all the connectors.
Yeah, so the battery here in this case is supplying electrical energy. When you buy a battery from the store, there's chemicals in there, right, that are, it's almost like potential energy, right? It has the potential to provide electrical energy to make something work, right? And that, after all, that is what energy is. By definition, it's the ability to do work, right? But
Cool.
the electrons won't actually flow through the wire. There won't be a current if the current is incomplete, right? So, for instance, we've seen birds sitting on a wire, right? A power wire. And they don't get electrocuted, right? Because the current's not flowing through them because they're not completing a circuit, okay? So it was only until, in this case, the switch was turned on that the fan actually worked, right? Can you share that again, Cynthia? Right, so there's a little connection there that's connecting the wire to make it a complete loop. So the electrons are now flowing through that wire. There's a complete current, and now it's not working because the loop is incomplete, right? Does that make sense? So that's a very good question. The other thing there's a green thing that's shaped like a weird looking triangle at the front there. What was that again?
The
That thing?
top one or the bottom one?
Well, I think the top one. Where's the transistor?
Yeah, that's the transistor.
That thing there, right there. So I'm now going to call on Seaborn. I gave him a heads up about this.
Yeah.
What
Yes.
is talk to us about a transistor.
So transistors, they have two uses. You can use them to amplify electric current, so you can get like a little bit of electric current and put it through a transistor, and it'll be a lot stronger. And they're like the little 3-prong thing with the black tip at the end. And then the other one is they also are a switch. I think a lot of them are in computers where they have a lot of little transistors. I think they store values of like a 1 or a 0.
Yeah, the binary code. Yeah, they can do that.
Yeah. Yeah, those are. I think that's right.
Yeah.
Yeah.
Very good. Yeah. So the first explanation there, Seaborn, can you repeat that?
So they amplify the electric current.
Right.
Pretty
Very
much. So like the microwaves have really, 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 really strong transistors.
Right.
To get a lot of heat. I wanted to take one of those, but I wasn't allowed to. So.
Very good. Radios are another thing, right? A radio station will want to, amplify the signal. What we're saying was we want to really get that radio signal out to a wide audience and cover a lot of area. So they'll have a lot of transistors in place so that people far away from the source of the radio station can actually pick it up. Yeah, very good. All right. Cynthia, do you have another one for us to do today? All right. So what are we building now?
Turn it off. She turned it off. That's him turn it off.
Give me a minute, please.
Okay, sure thing. Well, while you have a minute there, I'm going to explain something else with the circuits.
Okay.
All right, so I had said that this one here was in, is a series, right? This type of circuit here, the very simple loop, is in series. Well, in fact, there are actually different types of circuits. And I'm going to continue. I'm going to draw something else on this particular circuit. Let's suppose that there was, let's put a fan here. I'm going to do a little symbol for a fan. Oh, yeah, look at this. Okay, that's a fan there, right? Okay, so now we have something different, right? We still have one power source, a battery, but then we also have two loops here. We have one loop here, right? So we have a loop here, and then we also have, and this loop here has a light on it, and this loop here has a fan on it, right? And it just so happens that, let's see, I'll go back to my drawing thing. I'm going to put a little switch symbol. There is a symbol for this. I'm not familiar with the symbol, but this is a switch, right? And this is like a simple on-off switch. Okay, and this is currently set for off. So my question to the group, and let me say Jayla, I'm going to ask Jayla. My question is, which of these things that we're trying to run are actually going to be working? Will the light work and the fan, or will it just be the light, or will it just be the fan? Is Jayla there? No, she's not there. Does anyone want to have a crack at that? So as I've currently drawn this, which of the electrical instruments, the fan or the light or both, will work? Okay, so Angie, do you want to unmute your microphone and have a crack at answering this?
I'm just guessing fan.
Okay, so in this case, someone says the fan. So if you think the fan only will work, put a big thumbs up. Actually, the fan won't work in this case, because the switch here is in off mode. No, I should just write off, right? Off. So because the switch is off, the current can't flow through the wire into the fan. It can't do it, right? Because this part here is not connected. There's no way for the current to flow through. But the current can flow through this wire here, right? It can do that because the connections are complete, right? So if we were to put a switch here as well, and this is currently in the off mode, nothing would work. Absolutely nothing would work, right? Because the flow of current can't go through the wire, right? Now, when we switch this on, so now we put this on, right? So this is now, they're both on. Then the current will be able to flow through the wire. So it goes through here and it goes through here. So both the fan and the light will work. So this type of circuitry is called parallel, okay? Because in this case, we have two loops. We have a loop here and we have a loop here, and they are parallel to each other. They're being controlled by switches, which is what we would have in our house. But in this case, this type of circuitry is called being in parallel with each other. Make sense? So we've learned about two very simple circuits. We have series, right, which is like the first case. and we have in parallel, right? Now, in series, we might be able to do this. So if I just get rid of all this stuff here, right? And we have a light here, right? And we put a fan here, right? Here's my fan here, right? Now, we have two things that we're trying to operate. We have a light and we have a fan, right? But they're in series with one another. They actually, the current is on the same loop, right? So in this case, this would not be parallel. This would be series, okay? So that's the big difference there. So in the first case, and I think the second case, they were both in series. So I think Cynthia is set up to go here. And we will let you go and talk about what you've got planned here. Oh, this looks interesting.
Okay.
Good.
This is a sound activated switch.
A sound activated switch. All right. Excellent. Go for it.
David, stop. Stop it, David. David. Oh. Yeah. Okay.
So, do you want to talk about the parts first?
First, I'm going to talk about the parts.
Okay.
This is the whistle chip. This is the
Music?
This is the part that has the music. I forgot that.
That's okay.
This
Slide switch.
on me. Who's on me?
I got you. You're online here.
Oh, I got you. Oh, this is the slide switch again. This is the battery cap. These are the snap wires. There's two snap wires. There's a 5 snap wire. There's a 4 snap wire. This is the speaker.
Excellent.
And this is the red and black coils. Do you want to see how it works?
Absolutely. Yes, we're all on the edge of our seats here.
Okay. And you can touch the whistle chip to play it again. Oh.
I'm actually very interested in this. So when you touch the whistle chip, it works. How is this? Do you know how this works?
Well, not really,
Ah,
to be honest.
maybe what we could do here, if anyone knows, but we could put an explanation of this up on the website.
Okay.
Does that sound good?
Mm-hmm.
Interesting, intriguing. Does anyone have any questions that they would like to ask?
No, thanks, David.
So I'm interested to know, Cynthia, what other projects have you made with this kit?
If I had the real manual, I would show you, but I think I made a Space War circuit that showed
Wow,
the Space War.
that's pretty awesome. Adeline, did you say your brother had one of these kits? Do you know if he's made other things?
Is it the same brand? Oh,
It probably is. I think mine is the same brand too.
this is the one. This is the one on the Space
Oh,
World
wow.
combo.
So, and we'll post the link to this website because this is pretty cool. Yes. Yeah, and you know, I want to show you another thing. I know we've been playing around with this at YSA.
Raspberry Pi.
Yeah, Raspberry Pi. And it's just another form of a circuit board, right? Like a motherboard in a computer. You can see on the back there, there's all these circuits, transistors, and the whole bit, right? And, you know, we use these pins here, GPIO pins, and these wires that we're attaching to a sensor to actually complete a circuit, right? And we can do very similar things. So what you're doing here is really cool, and it can relate to appliances that are in our house and technology and things like that, right? So maybe, you know, next time what we could do is you and I could do something with the Raspberry Pi. Yeah?
Yes.
Let me know what you guys think. You can put that in the comments if you wanna do that. So did you plan on doing anything else today, Cynthia? Did you have any other things that you wanted to do?
Do I have enough time?
Absolutely, go for it.
Lamp and fan in series.
Ah, you're gonna do something in series?
Yes,
Yeah.
lamp and fan in series. I'll just show it to you.
All right, I love this. Science on the fly. Do you want to introduce your sister to everyone?
Okay, come on, excellent.
This is excellent.
Oh, no.
It's being tough.
Oh, that's okay, that's okay. You can go, you can go. Okay, let's just get this done with.
So let me ask, while you're getting that set up there, Cynthia. Oh, what do we got here?
This is the
In series. Okay. And so let me ask Joe, why is that, can you hold that diagram up again?
okay.
So Joe, why is that in series? Oh, he's not there.
Hold on. Let me see it.
I'll make it bigger as well.
That's okay.
Oh, okay. All right.
So why is that in series, not parallel? Anyone? It's because it's one loop, right? So everything is sort of flowing in series, right? That's the way to think of it. So it's just one loop in this case, and nothing's going to work if that loop is incomplete. All right, so Cynthia, you want to make this one? This could be the last one you make? Yeah? Great.
Do you want to see me make it?
Yeah, let's do it.
Okay. Okay, first I need this, the motor. This is the slide switch. One of these battery packs. Snap wires. Do I have a lamp socket? Okay. First I snap the slide switch here to the lamp socket.
What was that last one you said, the last piece? I missed that.
Oh, first I snap the slide switch here to the battery pack and snap the lamp socket to the slide switch. Then I snap this. I put this one here. I put this here.
Which is your favorite one to build so far, Cynthia?
I think all of them are my favorite because they're all very interesting.
That's very, very cool.
Okay, now I have to put this fan on. Then I'll turn it on. Oh, sorry. Sorry.
Hey, that's brilliant.
Excuse me for the noise.
What's the fan?
Oh, the fan just blew off.
It's flying saucer?
No. This is the Lambert fan series.
Oh, there we go. And then we just spoke about this on the diagram, right?
Mm-hmm.
Right. So we have a light there that's working beautifully. The fan's working beautifully. And if it's hot, you can actually fire this up and it's nighttime. There you go. You've got an instant fan with a light.
Mm-hmm.
That's brilliant. Excellent. So does anyone have any other questions?
Mm-hmm.
I think we're good. Seaborn, do you have anything to say?
No.
What about Cynthia?
What?
Check the chat.
Oh. Oh, thank you.
I have one more question.
Yeah.
So Cynthia, you've been like locked up in a house with schoolwork, and the last couple of weeks, what have you been doing to be active academically and things like that? What you got any tips for other kids around the US to keep busy in lockdown?
First do your schoolwork, then you can try doing exercises, healthy food or something.
Yeah, very good. Any exercise tips? You know, I've gotten back into riding my bike again.
I don't know how to ride a bike. Sorry, I don't know how to ride a bike.
So what exercises have you been doing? Push-ups, sit-ups?
Mm-hmm.
There you go. That's excellent. Yes, and it's a good reminder from Angie. Stay 6 feet away from people if you're outside. That's exactly right. That's why I like riding my bike, because I'm by myself. Yes.
Plus, my mom is teaching a class.
Ah, that's right. Yes. Yeah, I'm sure things are very busy for her as well. All right, Seaborn, are you ready?
Am I ready? Am I? I don't know. What am I ready for?
All right. Well, I'll do it.
Oh, you said okay. Okay, that's not something you'd normally say. Are you ready for? That's just something you'd. Okay. Yeah. Yeah. Okay. Yeah. Thank you, though. Thank you for the presentation.
Yeah, that was great, Cynthia. I'm really proud of you for putting that together, and keep up the great work. You know, this is really cool stuff, and it's amazing how something so simple can then grow into something big. And it seems complex, but not really. And I'm really proud of you for stepping up today and doing this. And we should do this again. We should do this again next week, right? We can build, you know, as I say, we can use the Raspberry Pi and do some more circuitry. Yeah. So everyone unmute your microphones, and let's give a big round of applause to Cynthia for her great presentation. Excellent, excellent. All right. Well, stay safe and keep up the good work. All right. Until next time.